Welcome to Section 4, Lesson 1, Video 2. Here we're going to continue to use a substitution strategy to solve a system of linear equations. Now in this video, we're going to look at a couple of examples that involve fractions, and one way that we can work around them. So we can do that by getting rid of the fractions by multiplying by the lowest common denominator. So looking at the first equation in A, we have a half x minus 3/4 y equals 7. So the lowest common denominator here, or LCD, would be 4. So we need to multiply each term by 4. So 4 times a half x, 4 times 3/4 y, and don't forget to multiply 7 by 4 as well. Even though it doesn't have a fraction, you got to multiply the whole equation by 4. So now let's reduce. 2 can divide into 4 2 times. 4 can go into 4 once. So now we just multiply what we have left. 2 times 1x and 1 times 3y. That would be 2x minus 3y. And on the right, we would have 28. So now let's repeat the process for the second equation. The only fraction I see here is 1 over 4. So that means the common denominator would be 4 here as well. So now multiplying each term by 4. I'm just going to reduce these 4's here to be 1. So I'm left with 4 times 3x, which is 12x, 1 times y, and then 23 times 4, giving me this equation here. So now writing these two equations together, this is a new system that we can work with. Now you don't need to get rid of the fractions. You can still use your substitution steps on the original question. It's just that working with this one might be a little bit easier. So now let's go ahead and do that. I'm going to follow the steps that were visited in the last video. So the first thing we do is solve for a variable. So looking at the two equations, the y here is the only one that has a coefficient of 1, so that's the one I'm going to solve for. And to do that, I'll just bring the 12x over to the right-hand side, giving me y equals negative 12x plus 92. Now we need to substitute that into the first equation right here for y. So I'll start by writing 2x minus 3, and then replace the y with negative 12x plus 92, and that equals 28. Now to simplify this, I'm going to do my distributive property. So multiplying negative 3 by negative 12x and 92, I would get this. 2x plus 36x minus 276 equals 28. Now let's combine those x's together to give us 38x. Now I'm going to isolate x by bringing the negative 276 over to the right-hand side, and then add that to 28, which is 304. Now to solve for x, I just need to divide both sides by 38, giving me an x value of 8. So now to solve for y, I'm going to replace x right here with 8. So that would give me y equals negative 12 times 8 plus 92, which is negative 96 plus 92, or negative 4. So now we can write our solution as 8 comma negative 4. Now the last step we talked about when doing substitution, or even when graphing, is to always verify your answer. So you can take a moment and replace x with 8 and y with negative 4 to confirm that this is the answer. Now for b, let's start by once again getting rid of the fractions. So for the first equation, I see we have denominators of 5, 3, and 30. So that would make the LCD 30. So now we can multiply each term of the equation by 30 and then reduce. 5 and 30 can reduce to 6. 3 and 30 reduces to 10. And 30 and 30 reduces to 1. Now multiplying what we have left would give us 12x plus 20y equaling 1. So now for the second equation, I see that we're going to have a common denominator of 40. So multiplying everything by 40, I would cancel these two to give me a 10. I would cancel 5 and 40 to leave me with 8. And 40 and 40 cancels to just 1. So now multiplying, I would have 10x minus 8y equals 7. So now I'm going to work with this system here. Now looking at the variables, I don't see that any of these have a coefficient of 1, so you just got to pick a variable and solve for it. I'm going to choose this x here in the second equation. So now when I do that, I would have 10x equals 8y plus 7. So now I need to divide each term by 10. Now I can reduce 8 over 10, leaving me with x equals 4 over 5y plus 7 over 10. So now I'm going to put that in for this x in the first equation. So now I have 12 times 4 over 5y plus 7 over 10. And then the rest of the equation, plus 20y equals 1. And when I do the distributive property, I only need to multiply the 12 by the numerator of each fraction. So when you multiply 12 by 4, that would give you 48 over 5y, plus 12 times 7 is 84 over 10, plus 20y equals 1. Now to combine my two y terms, I need to find a common denominator, which would be 5. So rewriting 20y with a denominator of 5 would be 100 over 5y. Now in the same step, I also reduced 84 over 10 to be 42 over 5. So now let's add our y terms. 48 over 5y and 100 over 5y gives you 148 over 5y. Now to solve for y, I'm going to bring the 42 over 5 over to the right-hand side. Then I got to combine that with 1 by finding a common denominator, which once again is 5. So now I have 148 over 5y equals 5 over 5 minus 42 over 5. Now subtracting that, I would get negative 37 over 5. Now to solve for y, I can start by getting rid of the 5 in the denominator by multiplying both sides of the equation by 5, and then canceling the 5's, leaving me with 148y equals negative 37. So now let's divide both sides of the equation by 148, and then reducing that, I get y equals negative 1/4. So now let's substitute that into our rearranged equation right here. So if I replace y with negative 1/4, I would now have x equals 4 over 5 times negative 1/4 plus 7 over 10. Now before I multiply these fractions, I see that these 4's can cancel, leaving me with negative 1 over 5 plus 7 over 10. Let's find a common denominator, which is 10. So now we got to add negative 2 over 10 plus 7 over 10, which is 5 over 10. We're just simplifying that. We get a half. So now we have our solution. X equals a half and y equals negative 1/4. So it's certainly possible for your answers to be fractions, like in this case. So you should now go ahead and verify that. So there's some examples of working with fractions. You can now move on to the next video in this lesson.